I've got 100k resistors, and I've got 27k resistors. And as you can tell, it's not an exact match. And I found that in electronics, when it comes to resistors, it's hard to find an exact match because they seem to have strange numbers. 27k, why 27k, why not 25k? I'm not exactly sure, but anyway, I found an approximate match, and this should be okay. And now, I'm going to demonstrate this thing working. So R1 is going to be 100k, and R2 is going to be 27k. So I'll start putting this together now. So this is 100k, which is the first one. There's power. 100k resistor. And the 27k resistor. Ground. We need something to bridge these two together. And we need something to tap into them. In other words, get V out. We'll get V out here. Okay. I'll connect my voltmeter up. So I've actually connected that incorrectly there. Move my voltmeter over here so you can see it. And now you can see what's happening. So we've given the circuit 5 volts and it's returning 1 volt. Let me just get the paperwork back. Okay. So our goal was 25 volts would equal 5 volts. 25 volts would equal 5 volts. Let's put it up a bit more. There you can see it's not far off. So if I reduce this down now to half, let's say 12.5 volts, that should be around about 2.5. And it's 2.7. So you can see how it works. With 5 parts, 4 parts are resisted off, and 1 part is read here. It's down to 6. And it reads 1.3. Earlier I mentioned that another use could be level shifting. So let's say you have a 5 volt Arduino and you have a 3.3 volt ESP. And now let's say you're using serial to transmit data between the two. So the Arduino, no, let's say the ESP is sending data to the Arduino via serial. So the ESP is transmitting and the Arduino is receiving. The ESP may be giving data with 3.3 volts. The Arduino, however, may be giving data to the ESP using 5 volts. And some devices are sensitive to 5 volts and different voltages, and the ESP is one of them. It can't accept 5 volts. So what we have to do, or what we could do, is use a voltage divider to get the Arduino's transmissions and resist off a percentage of them. So if we use our algorithm again, the input voltage is 5 volts and the output voltage is 3.3 volts. Sorry about that dot there. 3.3 volts. So if we calculate that, that will give us 1.5. Now that 1.5, if you remember rightly, we have to take 1 off it, and R2 equals 1 as far as the ratio is concerned, and R1 equals 0.5, because take away 1 is 0.5. So that's the ratio for this particular voltage divider. So if this was 100 ohms, then this will be 50 ohm. And so, like I said earlier, it's the ratio which matters. So I'm going to look for some resistors which will make this work. And there's one more important thing that I meant to tell you. You can actually put resistors in series which collectively make up that resistance. So I'm going to find some resistors now, and I'll show you this demonstration as well. Okay, I've found some 100 ohm resistors. But like I said before, the resistance doesn't matter. It's the ratio. So this is what I'm going to do now. I'll get this back here. And now take out these old resistors. And I'm going to take 3 of these resistors. Now, I've got the input there. I'll put 1 resistor in here. Another resistor in there. And then another resistor in there. So now I've got 3 resistors in. But remember, you can use these in series. So what I've got here, if I go back to this little thing here, so I've got 50 ohm and 100 ohm, but these are all the same. So these are all 100 ohm resistors. So I'm going to do this. I'm going to use 100 ohm, and then I'm going to use 200 ohm, which the ratio is the same. That is double that, and that is double that. So the ratio is the same. And I'm going to use these two in series. So if I put the V out pin there, that will work. I'm going to demonstrate this now. So I'll put this up to 5 volts. And now this should be 3.3 volts. Or 3.4, okay, close enough. So here we've used it as a level shifter. I'll just show you this again. So there we go. And that's the basics of voltage dividers. And there are a couple of considerations as well I'd like to finish on. Firstly, you should remember that voltage dividers work on fractions. So the output is a fraction of the input. The second thing to remember is that if your input is higher than you expected, then your output will also be higher than you expected. So for example, with a 25 volt input, if your divider is set up in such a way where you'll get 5 volts max, or that's the particular ratio, then if for whatever reason this is boosted up to 50 volts, then this will be boosted up to 10 volts, which of course could blow your microprocessor. So you have to be wary of that. The second thing is that you can't always seem to get the exact ratio that you need. Sometimes you have problems finding resistors. You need to check the values, because sometimes if you get a 1 mega ohm resistor, sometimes it's not a mega ohm. Sometimes it could be 1.02 or 1.05 or something like that. And the other thing is to remember that if you are using this for a microprocessor, remember to overestimate your input, or I do anyway. So if you think that your maximum input will be 24 volts and you need to output 5 volts to a microprocessor, consider bringing that up to something else. I mean, in my solar project, I measure battery voltage and I allow up to 30 volts and I output that to 5 volts. So the chances are it will never ever reach 30, but if it did, it would never output more than 5 volts, and therefore my microprocessor will be less susceptible to damage from the divider. And that brings this video to a conclusion. And once again, thanks for watching. Bye!